Our last House of Evans startup is 3E Nano. We will hear from Steve Ferrero. Steve was voted most likely to take the idiom, "The eyes are the windows of the soul," too literally.
All right, very good. Thank you. Hi, everybody. I'm Steve Ferrero, CEO of 3E Nano. And 3E Nano is all about bringing solar control to polymer-based architectural applications. I worked for 34 years in the polymer industry and discovered that 3E Nano's solution was 10 times better than anything that exists in the market today. We provide a path for improved energy efficiency and decarbonization of infrastructure with our solar and energy control coatings. So polymers are used successfully in northern cooler climates, but due to lack of solar control, they can't be specified in warmer climate zones. The revolution that we're bringing to the market is to enable polymer materials to have solar control, which opens up billions of dollars of revenue to our customers who can now sell in expanded geographies around the globe. We've invented a transparent heat filter. It filters heat from light, and it allows the light to pass through, but reflects the heat. The coating gives you a natural view of the world. It's high light transmission. It's always on. It needs no electricity, unlike a dynamic window, which uses electricity and goes dark to block energy. In that regard, we're better and less expensive than those systems. Dynamic windows are also absorptive and not reflective, making them less energy efficient. So when we look at a matrix of light transmission and solar performance, and you consider the better insulation value of polymers, we are in the high category, making us standing out from the competitive systems. Compared to laminated glass systems, the polymer-based systems are 4 times lighter. They require 3 times less steel and concrete and to support the structure. Films can also be considered a competitor, but they are difficult to handle for consumers. They're absorptive, and they are not made for polymers, and they do little to address the insulation problem. We are focusing on transparent architectural polymer-based applications. These applications already exist. However, with solar energy control, these applications can be found in applications all over the world, in airports, hotels, malls, restaurants, train stations, in both new and retrofit, in commercial and residential building applications. So our business model is that we will put our coating on our B2B customers' polymers, giving them new solar control capability. Now armed with this new capability, they can sell their upgraded products in all climate zones with no restrictions. Now they can sell applications both in Denmark, but also in Dallas and in Denver. We are pre-revenue, but it's our goal to capture 1% of the global architectural market, which will make us $1 billion company. There are huge opportunities for our solution, and we're looking for strategic partners operating in the built environment and energy efficiency space. We're raising $800,000 of equity for milestone 1 of a 3-year commercialization project with a Canadian government agency working on reducing greenhouse gas emissions. The milestone 1 funding will come with an $800,000 non-dilutive grant. And overall, the 3-year project will offer $4.7 million in non-dilutive funding, which will enable us to be fully commercialized by the end of the project. We are a diverse and cohesive team of 8 with polymer, plasmonic, and photonics experience. The co-founders have prior startup experience as well as deep business acumen at the senior VP level of Fortune 100 companies. I have in-depth experience in creating innovative technologies for polymer applications to expand markets and create value. We'd be excited to speak with you if you can contribute to or connect us with partners to test our energy efficiency and decarbonization potentials. I ask you to join us in disrupting the architectural space with the disruptive idea of using nanotechnology and polymers to fight climate change. Thank you.
Thank you, Steve. We have a question in chat from Rob Tucci. Does your coating interfere with radio waves?
There are patternings that can be done on the coating to allow it to transmit radio waves. including 5G signals. And actually, the coating can be used as a transmitter for 5G signals as well.
Okay, next question. What's your next milestone and how much do you need to raise to get there?
The next milestone is that we will prepare roll-to-roll production samples on commercial equipment and provide those samples to our customer. And basically for 8 months of the first milestone, we'll be raising $1.6 million to support that and the work of the company, half of which will be non-dilutive.
Great. And then next question. So you're suggesting a conversion of windows from glass to polymer. Is that correct?
Partially correct. There's polymer-based applications already used in the market. And however, a major glass to polycarbonate conversion happened in the world in the area of automotive headlamps, where all headlamps used to be glass. And in 1984, the first polymeric headlamp, PC headlamp, came into existence. And in less than 10 years, the entire world switched over to polymeric headlamps. And that's still the dominant technology today. We actually have a slide on that. It only took 10 years to convert over globally to this new material because of the advantages.
Question from Tina with GC Ventures America. How do customers apply the coating? Any CapEx requirement?
So the coating will be produced at people's plants that make the substrates, and it'll be laminated online. So we'll supply rolls of film with our nano coating on it, maybe 2 kilometers long. And while they're manufacturing the substrates, whether it's acrylic or polycarbonate, they will integrate it in their line, in their plant while they're making the substrates. And that's how we incorporate the technology into their products.
Kind of along the same lines, can the product be applied in situ, or in other words, can it be applied to existing buildings, windows, etc.?
Well, the window insert concept that you see here, there's already existing rigid applications, but they don't have solar energy control, as most of these applications don't. So our business model is really to work with substrates that already go into these type of applications. And in this case, it would create turn a single pane window into a double pane window, but also with a low E coating, so that it can be a DIY retrofit, say for an apartment, where you could turn your normal leaky, energy inefficient window into a low E, high energy efficient, high thermal barrier window opening.
And then last question, there's actually 2, but they're similar. So I'm going to read both.
All right.
What is the expected degradation over the lifetime? And another way of asking, are there any similar problems to the polycarbonate headlamps where they yellow and haze over time?
Yes, that's an issue that was created due to the specification of the lifetime of the headlamps that they designed for a 10-year lifespan. We are designing for a 20 to 30-year lifespan. And another thing is that the coating we have is UV blocking, so it protects the polymer from seeing UV, and it also rejects heat, so it keeps heat out of the polymers. And those 2 things will extend the life of the substrate.
Okay, for those questions that weren't addressed, Steve, please address them in the Q&A box, or please, if you're an attendee, reach out to Steve and 3E Nano.
Okay, very good. Thank you.
Now we're going to transition to a brief 2-minute break. But first, I want to thank Mike, Jason, Danny, Mac, and Steve. And when we come back, we'll hear from Caroline Walkman.